Hello students, so let's continue with the last part of Unit 1. So here today's agenda we are going to see about the introduction, the components and we'll see what is meant by closed loop system and open loop systems. So first before touching our topic, so let's revise what is meant by cyber physical systems. So integration of computation, networking and physical processes along with other computation network, we call it as cyber physical systems. So here we have real-time interaction between digital and physical worlds, and we have some examples. For example, like autonomous vehicles, smart grids, and Internet of Medical devices. Everything comes under CPS systems. So moving on to the next part, we have core components of CPS systems. So already we have seen this. So the key components are sensors, actuators, and embedded systems. So we have local processing and control. Control can be considered in embedded systems. So here we are going to see what is meant by a control system. So control system is a system in which the behavior of the system is determined by a differential equation. So basically the control system is nothing but it controls the subsystem or the system of systems, right? So it manages the devices and the systems using control loops. So in control systems, we have various engineering and automation processes, and now the control systems are considered to be an integral part of IIoT. So they are responsible for the regulation and the behavior of dynamic systems, so we can achieve desired outcomes. So when you consider a controller, the controller can have some essential components of control systems. So it plays a critical role in maintaining the stability and its efficiency. So you know what is meant by control system? It's nothing but it controls the subsystem of systems. So next part we are going to see about what is meant by open loop control system. So this particular system is used in applications, and here we don't have any feedback, and error handling techniques are also not followed. So it is very simple compared to the closed loop system, and it is economical, but optimization is not possible here in open loop control system. So overall the maintenance is very easier in open loop control systems. So moving on to some advantages of open loop systems. It is very simple to design and implement. So there is no need for feedback or any other a loop over process. So low cost, and it is maintenance is very easy. So high speed of operation can be done, and it can be used for systems that don't require precise control. So these are the advantages. So next, moving on to the disadvantages of open loop control system. So there is lack of accuracy and precision. So we have some external disturbances and other variations in open loop control system, and this system is not suitable for high degree of accuracy and precision. So already we have discussed all these points. So this is the exact block diagram of a open loop control system. So if you take this block diagram, we have input and output. So in this block diagram, the input represents the desired set point. So it can define the system, what it has to achieve, right? So that is considered to be the input, and here we have a controller. So controller is like a processing block, which is mainly used for processing the input, and it generates control signals based on some algorithms and commands provided to the controller, right? So controller process represents the physical system, so that is controlled by controller block. Okay, so basically here we have so many types of requirements. So any type of input can be provided, so it can work under mechanical engineering, electrical engineering, or any other system based on the requirements. So next, moving on to the next part, we have gain of open loop control system. So we are going to see what is meant by gain of open loop control system. So here in gain in the system, it is nothing but it's considered to be the amplification factor which is applied to the input signal, and it produces the control signal. So we have a block diagram for gain of open loop control system. So let's see the block diagram and we can understand it more clearly. So we have a gain controller block. So it can be considered as G1 of S and G2 of S. We have the processing control processing unit. So let's understand with this block diagram for gain. So first it is the input. So we have represented input as Xi of S, and next we have the controller G1 of S, and next we have the controlled process which is represented as G2 of X, and next we get the output, so that we call it as X0 of S. So inside controller, in between controller and control the process, we have control signal. So we that is represented as X1 of S. So let's continue with the relationship of the gain of the system. So we can consider the magnitude of the input and the output signal. So when you consider this type of system, gain of the system is represented as G of S, so which is equal to output signal divided by input signal. So in the previous diagram, you know what is represented for output signal. So output signal is represented as X naught of S, and input signal is represented as Xi of S. So gain of the system is represented as G of S, which is equal to output signal divided by input signal. So G of S is equal to, straight away we can write the term for output signal. So X naught of S divided by input signal, that is Xi of S. So where G of S is the gain of the system. So in the given block diagram, we can specify G1 of S as G of S as G1 of S is equal to X1 of S divided by Xi of S. So similarly, we can write G2. So it can be written as output divided by the input. So X naught of S divided by X1 of S. So G of S can be written as G of S is equal to G1 of S into G2 of S. So how do you solve this? So writing the value, substituting the value of G1 of S and G2 of X. So the final value is X naught of S divided by Xi of S. So G of S is equal to this particular part, the last term. So X naught of S divided by Xi of S. So we have found out the gain. So the new block diagram can be drawn in this way. So I told you in the previous slide, so G of S is denoted as G1 of S into G2 of S. So input is considered as Xi of S and output is considered as X naught of S. So it can be written as G of S is equal to G of S is equal to G1 of S into G2 of S. So moving with the working of open loop control system. So first we'll be discussing about the working of open loop control system. So here we have to consider the input signal, and you have to make note of the controller, and we have to see what is done in the output device. So if you consider this particular working, so we know the open loop control system works with the process of the signal, and this system is basically used when the output signal is not feedback control, and also it is very simple to operate. So first the input signal is converted to electronic signal. through input device. So after detection, after the signal passes to the processor for further process. So initially input signal is converted to electronic signal, and then coming to the controller part. So the controller converts the signal to output signal with the accuracy, so that the desired output signals value should match with the input signals value. So this particular information is sent to the output device. So when the input signal is processed through the controller, it is passed through the controller, and then from the controller it is passed to the output device. So the output device converts the signal to electrical signal, so which has the system's output. So this is the working of open loop control system. So in the next part, we will see some examples of open loop control system. So we have some applications with the open loop control system. So first thing is electric fan. So if you consider electric fan, the regulation of fan speed using a regulator is a classic example. So here we have an open loop control system. So this is an example for an open loop control system. So here the input is the electrical power. So whenever you switch on the fan, you give an electric power, right? So controller is centrally located shaft that rotates, and the output is the fan's rotation speed. So this is an example for an open loop control system. So moving on to the second example, we have oven temperature control. So how do you operate ovens? So you know the operation, right? So that also comes under open loop control system. So many ovens operate based on open loop control system. So in this case, we can set the desired temperature. So the oven heats up the food inside, and with that temperature, without continuously monitoring the actual temperature, we can manage the overall functions of the oven. So next we have washing machine cycle selection. So when we choose a washing machine cycle, so it is based on the type of clothes. The programs are already predefined in the embedded systems, right? So based on that particular operation, it works. So this is also an example of a open loop control system. And next we have remote control for electronic devices. So for example, we can say remote controls for TVs and other electronic devices. So it sends commands without receiving feedback, and about whether the device successfully executed the command. So considering the components of feedback, the feedback control system consists of 5 components. So we have seen all the basic components earlier in this unit. So once again I will tell you. So here we have reference input or command input. So this input is applied to the whole system, and we call that input as reference input. So considering the input, so the input process transforms the form of the input into a different form. So that is utilized by the controller. And next we have output. So this measures the response of the output, and it transforms it into the form used by the controller. And next we have the feedback part. So it is the return way to the summing intersection. So from this you can get a proper output response. So it has a feedback component which gives back the output response, and it can have some error detector also, right? So basically you have to know about the error detector also. So an error detector obtains the calculated signal from output response. So it also compares with the reference input. So basically it provides or it gives the error signal by the difference of two signals. So considering this difference, the difference we call it as activating signal. So next part, we have characteristics of an open loop control system. So if you look into the slide, we will see what are the characteristics. of open loop control system. So here we don't have any feedback. Straight away I told you about the block diagram. So there is no feedback from input till the output. So in between you have the controller. So there is no feedback from the system. So that's the characteristics of an open loop system. So based on the stability, as there is absence of the feedback in the system, the error in the system is not corrected. Okay, so whenever you have a feedback, the errors can be corrected and it can be an evolutionary process. So in this particular case, we don't have any feedback, so errors are not corrected, so which leads to reduce of the stability of the system. So stability of the system is reduced. So next we have fast response. So open loop systems are much more faster than a closed loop system, since there is no feedback loop present. So the design is also very simple. So these systems are very simple in design compared to closed loop system. And moving on to the applications of open loop control system. In open loop control system, we have some applications. We'll see some examples. So light switches, you can say it comes under open loop control system. Simple appliances, traffic signals, robotics, manufacturing processes, everything comes under open loop control system. So when you consider open loop control system, so here the feedback are not critical, right? So the control process is little bit precise. So for example, say light switches, so you can turn on or off light basically with a switch, so that we can call that as a simple open loop control system. And for examples like devices like blenders and toasters often use the basic open loop control system. So these are the basic operations. And traffic systems, robotics, manufacturing processes, everything does not have any feedback. So we can say these are the applications of open loop control system. So we have an example for open loop drying system. So here it's an application. So in the first block we have timer, and in the second block we have heating elements, and in the third block we have clothes. So basically an open loop system works with the input and output. So here the desired time is given as the input, and the output is the actual dryness. So for example, let us consider an electronic clothes dryer. So on the basis of the amount of clothes on their wetness, a particular user sets a timer, or it can be called as a controller, right? For example, say 30 minutes. So this machine will work for 30 minutes, and it will automatically stop and turn off even if the clothes are still wet or damp, right? So this example shows an example for open loop system, and it does not monitors the dryness of the clothes, right? So it gives some output signal. So the output signal is nothing but the dryness of the clothes, and it does not always monitor the dryness. So this is the block diagram given here. So we have some disadvantages of these open loop system, so which does not have knowledge of the outputs. So it is not so we cannot conclude that there can be any errors, but we have some errors when the output has any deviation. So open loop system is poorly handled with basic disturbances or change in some conditions. Again, for example, we can say in the drying system, if the door remains open of the dryer, then the heat will be lost, right? So if the timing controller continues to run till till the completion of 30 minutes, so which can lead to incomplete drying of the clothes. So these are the basic examples of open loop control system. So it does not, it gives you an output, but we cannot say how accuracy the output is. So here we have open loop drying system again with some disturbances. We have so controller has some disturbances. So we'll see how this particular process works. So we have to solve this error free feed forward control, and which is used with the type of manual system, so which can act before the error. So considering this example, if the user closes the door, so the dryer very quickly gives the system error, which will be minimized. So but however, then the feed forward control is not always the correct approach as the system changes. So moving on to the closed loop system. So we have a closed loop system. So it's used in applications where feedback and error handlings are required. So always in a closed loop system, we have feedbacks and error has to be handled. So it is a complex system compared to open loop system, and it is not economical, but optimization is possible here. So maintenance of this closed loop control system is very difficult. And next, moving on to the advantages of closed loop system. So in closed loop system, the thing is, it gives high accuracy and precision. So it is robust against external disturbances and variations. So even if there is any external disturbances and variation, based on the feedback and the things, other suitable things, it can rectify the errors, and the accuracy is really high compared to the open loop control system. So this particular system is suitable for systems that require a high degree of accuracy and precision. So moving on to the disadvantages of closed loop control system. So it is very complex to design and implement. So the cost of maintenance is also very high. So when you compare the speed of the operation, the speed of the operation is very slow compared to open loop control systems. So here we have an example. So this is the block diagram of closed loop system. So here we have the input and the controller system output. So basically we have a sensor. So again it is given as feedback. Then the process is repeated from the controller, and again the output is generated, and the process continues till it gives a um, high accuracy value. So we can see some similarities between open loop control system and closed loop control system. So when you consider both systems, both types of control systems aim to achieve a specific output or goal. So in both the systems, we are going to achieve a specific goal. And the second thing is, both types of control systems use sensors and actuators to measure and control the output. So both the systems use sensors and actuators to measure and control the output. So here both the type of control systems rely on feedback mechanism to monitor and adjust the output. So next we have mathematical models. So in both the systems we use mathematical models and algorithms to calculate the output. And the last point is, both the systems can be used in various applications such as industrial control, robotics, automation, etc. So these are some similarities of open loop control system and closed loop control system. So here basically we can see some differences of open loop control system and closed loop control system. So first I told you the difference. So since the architecture of open loop system is very limited, so it is easier to build. Considering the closed loop control system, it is very difficult to build. So it can perform better if the calibration is properly done. So this is the major difference in open loop system, and it can perform better because of the feedback. So the open loop system is more stable, So in a closed loop system, it is comparatively less stable compared to open loop control system. So optimization for desired output cannot be performed. So here in closed loops control system, optimization can be done very easily. And based on the feedback mechanism, it does not consist of feedback mechanism. So in closed loop control system, we have some feedback mechanism. So this particular system, open loop control system, requires less maintenance, and closed loop control system, the maintenance is very difficult. So open loop control system is less reliable, and here it is more reliable. So it can be easily installed and it is economical, but in closed loop control system that is not the case. Complicated installation is required and it is very expensive. So these are the major difference between open loop control system and closed loop control system. So next we'll go to the final part. We have learned till now we have learned about open loop and closed loop control systems. So these are the two main categories in the control system. So I told you what is a control system initially in the first slide, first 2 3 slides. So this control systems that are used to manage and regulate the behavior of physical systems. So with both the types of systems, we have so many advantages and disadvantages. So based on some feedback, we'll be using closed loop control system. So with the feedback system, it is considered to be more stable. So I'm talking about closed loop control system. So it is more stable compared to open loop control system. So as technologies evolve, we are likely to see more closed loop control system being developed to manage and regulate a wide range of physical systems. So that's all about open loop and closed loop systems. So till now we have learned about the various IIoT methodologies. We have seen what is meant by IoT nodes, what are the challenges of IIoT. We have seen so many architectures of IIoT and so on. So almost your unit 1 is over completely. So I'll be posting the quizzes and other assignments. So kindly look into it. And yeah, so we are completing unit 1 today. So thank you all for listening. Thank you.